So the next test here, 13.1B, exercise 13.1, these questions, okay. So B5 on page 229, we'll start with that. Let me read the question for us. A cubical box has H 10 centimeter, another cuboidal box is 120. Okay, so let's just draw the cubical box first. There's a cubical box means the box is cube shape. So this is the cubical box. Cube means everywhere is the same, so H is 10 means here also. Length is 10 centimeter, breadth also same, then height also same. That's called a cubical box or cube. Another is cuboidal. So the next box is cuboidal. 12.5 long, 10 meter wide, 8 meter high. So 12.5 meter long, 10 centimeter long. Okay, 12.5, 10 centimeter long, and then height is 8 centimeters. So it's the shortest the height is. So this is the picture. So 12.5 centimeter long, 10 centimeter wide, and 8 centimeter high. So which box has greater lateral surface area and by how much? First one. So right is dimensions first. Dimensions of the cubical box. See, the H EDGE is denoted by A, 10 centimeter. Then dimensions, here dimension is enough, dimensions of the cuboidal box. Its length is 12.5 centimeter long. Its breadth is 10 centimeter long. And its height is 8 centimeters. So this is the height. Right. Number one question, let us answer this. Number one, which box has greater lateral surface area and by how much? So we have to find the lateral surface area separately first, because we don't know which of these two boxes more greater lateral surface area. We have to find separately. So let us find out the lateral surface area of the cubical box. Lateral surface area of the cubical box. You know, lateral surface area means this side walls, the four walls. So that is equal to twice. For lateral surface area of a cube, we learned from the first class that it is 4 multiplied to a square, the four walls area of a cube. So that will be equal to 4 into 10 into 10, because a square means 2 times 10, and area means therefore centimeter square. Always two-dimensional area, lateral surface area. See, so this will be 400 centimeter square. That is the lateral surface area of the cubical box. Likewise, lateral surface area of the cuboidal box, this time cuboidal box will be, yes, they're using cuboidal, so lateral surface area means it's four walls area only, same thing, or we did not even write four walls area formula, same. So twice H into L plus B for a cuboid. In the first chapter we learned this, so this is twice H is here 8 centimeter L is 12.5 plus B is 10. And instead of putting centimeter here and there, we just put ones here. Centimeter square, because area means that two-dimensional. So this is 2 8s are 16. 12.5 plus 10 is 22.5 centimeter square. So our answer is, you multiply these two, you do this on the rough because you'll need it. 6 5s are 30, 3 in hand, 6 2s are 12, plus 3 in hand, 13, 14, 15. So 1 in hand, 6 2s are 12 plus 1 remainder, 13, then 1 5s are 5, 2 and 2, 0, 10, 6 and 3. As you add, one decimal place only, because on the right, no decimal here. So right from here, one place jumping. So between these two zeros, so 360 centimeter square is the lateral surface area of the cubicle box. That of the cubicle is 400. So clearly the cubicle box has greater lateral surface area. Question is saying which has greater lateral surface area. So our answer is found the cubicle box has a greater, the cubicle, let's just write in statement from the cubicle box has greater lateral surface area. And you can say, and it has, means the cubicle box has greater lateral surface area by how much? Means by how much is it bigger? The answer is the bigger one, 400, minus smaller one, this much, close bracket, and write centimeter square at the back. So by 60 centimeter square area, the cubicle box has greater lateral surface area. So that is 360 and 400 minus 360 is 40. Okay, first answer. Then let's go to 2. Second point is, let's read the question. Which box has smaller total surface area? We don't know, so we find again total surface area separately of the cubicle box. Let us find first. Formula of total surface area of a cube is 6a square. From our first class, we know the formula. So next, that will be equal to 6 into 10 into 10, because a square means 2 times and centimeter square. So that is 600 centimeter square. And then right here, total surface area of the cuboidal box. That is, we know cuboid formula is 2 into LB plus BH plus LH. We know this from the first class. So 2 into L, 12.5 into B, 10 plus B into H, so 10 into 8 plus L into H, so 12.5 into 8. And instead of putting here and there, just put centimeter square once at the back. That's enough, because it's area, total surface area. Slowly let's do 2, 1, 0, push this to the right, so no more decimal, 125. 10 into 8 is 80, and 12.5 multiplied to 8 is 8 5 is 40. 4 in hand, 8 2s are 16 plus 4, 20, 2 in hand, 8 1s are 8, 9, 10. 1 decimal, so here, so this 100.0 means 100 only. So next, quite simple I think. 2 into, very simple, 100 plus 125. Okay, 100 plus 100, 200, 280. 20 is here, 80, 90, 305. I think very simple if you use your common sense. 100, 200, 280, then plus 20, 300, plus 5, 305, this much centimeter square. So this is 610 when you multiply 2 to 305. So that is our total surface area of the cuboidal box is this time greater than the total surface area of the cuboidal box, cubical box. So your answer is, which one has a greater total surface area? So your answer to that is, this time the cuboidal box has greater total surface area, and its total surface area means cuboidal box is greater surface area greater by a value or by a number bigger minus smaller. So 610 minus 600 bracket, and common centimeter square can be put up, centimeter square. So the answer is equal to, by 10 centimeter square, the cuboidal box has greater total surface area. Okay, so we have done B5, and now let us go to the B6. B6 is, okay, let me read the question. B6. A small indoor greenhouse herbarium for keeping plants is made entirely from glass, including the base, means the floor, held together with tape, solid tape. It is 30 centimeter long, 25 wide, and 25 centimeter high. So let us draw the herbarium glass house. Clearly cuboidal because length, breadth, height is given. So here the length of the house must be, glass house must be 30 centimeter long, 25 centimeter wide, and 25 centimeter high. So let's just write here dimensions. Here, dimensions of the herbarium glass house. Herbarium glass house, or herbarium, that's all, of the greenhouse, or whatever you like to put, of the indoor greenhouse. So you can just write greenhouse made of glass. The length is 30 centimeter long, they are saying, so its length is 30 centimeter. The width is 25 centimeter. It is that much wide, so width WIDTH. And the height is also 25 centimeter. This size you have to make totally with glass, including the base. Now, what is the area of this glass? Number one, what is the area of this glass? Since, according to the first statement of the question, the greenhouse means it is, according to your question first statement, it is made entirely, made entirely of glass panes, means glasses, flat sheets of glass, including, this is important, including the base. Therefore, question number one, what is the area of the glass? So area of glass required to make this is, area of glass will be equal to total surface area, which is total surface area of this cuboid is 2 into LB plus BH plus LH. And we may as well go here. That will be equal to 2 into L is 30, B is 25 plus B is 25, H is 25 plus LH. So L is 30 into 25 and centimeter square. You can just put it once at the back. So they'll give you 2 into 3 5s are 15, 3 2 are 6 plus 1 7, 750 plus 25 into 25 is 625. Again 30 into 25 same, so here 750. LH, BH, LB, LH. Yeah, same. So this is, to make it simple, 750 plus 750 common sense, 1500, 1500. So 1500 plus 625, 5 2 11 2. So 2125. When we add this 1500, this 2 plus this, write on your graph centimeter square here also. Centimeter square. So 2 5s are 10, 2 2s are 4 5, 2 1s are 2, 2 2s are 4. So total area is 4250. Okay, centimeter square of glass area is going to be required. Then second part, how much tape is needed to cover the edges? So this one here, the glass house, including the base means top also, everything. You have to put solid tape to join the glasses. So it has 12 edges. We learned in the first class. A cuboid has 12 edges. 4L, 4B, 4H. So 12. So since number 2, it has 12 edges. We learned this property of cuboid. By looking at the box also, we know there are sharp edges to join glass, this glass with this glass, solid tape. So 12 are there. 1, 2, 3, 4, 5, 6, 7, 8, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So that means since it has 12 edges, that is 4 lengths to put the solid tape, 4 breadths to put the solid tape, 4 heights to put the solid tapes. Therefore, how much of tape is needed? Tape, TAP, solid tape, okay, so tape length needed, common sense will tell you, is solid tape to put on 4L, so 4L plus 4B, 4 breadths edges are there, 4H edges are there, so this is the one. So if you take out the 4, then L plus B, 4 into L plus B plus H, this much solid tape. 4 into L is 30, B is 25, H is also 25. Since this is length, it's only single dimension, area is 2 dimensions, so centimeter square, length only 1 dimension, so not centimeter square, centimeter. 4, simple to add, I think 30, 25 plus 25, 50, that's easier, plus 30 is, so to do this 2 is easier, 50 plus 30, 80. That way we don't need to go to rough and calculate. So this will be equal to, here, 4 8s are 32, 320 centimeter long of solid tape is going to be needed to entirely connect the edges to make the herbarium. So that answers your 6 also. We'll do the 7 and 8 in the next class. Okay.